Hello and welcome to Aditya classes. Now today we will be taking this particular question and will be formulating an LP and solving it using Simplex. Fine. So first we need to formulate an LP for this. What is the situation? The situation is that there is a company that produces products A, B and C. So company is producing products A, B and C and variable costs of each are 8, 5 and 3. A costs me 8 rupees per unit variable cost. B costs me 5 rupees and C costs me 3 rupees. Along with this variable cost there is a fixed cost which is 12,000. So that 12,000 is apart from this variable. So when I am through with all my production, the total cost will be component of variable of A, component of variable of B, component of variable of C plus this fixed cost. So this is my total cost. In any case, for now fixed cost is 12,000. Variable costs of A, B and C are 8, 5 and 3. Contributions of A, B and C are 2 rupees, 1.5 rupees and 1 rupee. First let us see whatever is written over here, then we will discuss over it. Fixed cost is given, variable cost is given, contributions are given 2, 1.5 and 1 respectively. Need to produce at least 300, 200 and 500 units of A, B and C respectively. So there is a boundation, there is a constraint that you need to produce at least 300, 200 and 500 units of A, B and C. You will have to produce these. Then determine optimal product mix at break-even point. Determine optimal product mix. So I will be taking up some combinations of A, B and C. How much of A, how much of B, how much of C. This will be my product mix. Determine optimal product mix at break-even point so that total variable cost is minimized. Total variable cost is minimized. Now this is a big difference in absence of just this line. Determine optimal product mix at break-even point. I might have tried to maximize my profits. My contributions are given. I might have made an effort to optimize or maximize my returns, my contributions, my profits. But because of this line, determine the optimal product mix at break-even point so that total variable cost is minimized. During formulation, I told that if the question explicitly mentions that maximize this or minimize this, then definitely we go for that. But in absence of anything, if they simply say that optimize the problem, in that case what we do is, if profit is talked about, we try to maximize it. If cost is talked about, we try to minimize it. If both are talked about, cost and profit, then we try to maximize profit. In formulation, if you have gone through those videos, I said if cost is talked about, only cost is talked about, we try to minimize it problem. If profit is talked about, we try to maximize the problem. And if both profit and cost are talked about, we try to maximize it. Why? Because ultimately we are in business for profit. If I have an idea what my profit can be, then I will try to maximize it. If I have some idea what my profit will be, no matter what is the cost, I will try to maximize it. So the idea is, if profit is given, we definitely try to maximize it. Contributions are given, I would have tried to maximize the contributions, but the question explicitly says, so that total variable cost is minimized. So this will be important in our formulation. Formulate LP and solve it using Simplex. So let us get on with our formulation bit. Now before we get into formulation, let us talk of the situation. What is the situation? We need to minimize the variable cost. So there is no fun looking at anything else. Objective function is clearly mentioning that you need to minimize the variable cost. Where is the variable cost? Here is the variable cost. How much variable cost I will be incurring? 8 multiplied by number of units of A that I produce. 5 multiplied by number of units of B that I produce. 3 multiplied by number of units of C that I produce. This will be my total variable cost. So, for formulation, let me say that let number of units of A being produced is equal to A. Let number of units of B being produced is equal to B. Let number of units of C being produced is equal to small c. So, for ease, what I have done is, I am saying that I will be producing A units of this, B units of this and C units of this. So, what will be my total variable cost? 1 unit costs me 8 rupees. So, A number of units will cost me minimized Z min. A number of units will cost me 8A. 5 B's and 3 C. I will be producing A units of A, B units of B and C units of C. So, my total variable cost will be 8 into A, 5 into B and 3 into C. This declaration I have made. This is not straight. Also, we need to make a declaration that what is Z? Capital Z? Capital Z is total variable cost, and my objective function would be Z min is equal to 8A plus 5B plus 3C. Fine. If you remember formulation of a linear problem, first step is decision variables, key variable, objective function. Fourth step is the constraints. So, I have first, second, third step. Fourth step is constraints. Constraints. What are the constraints for me? Constraints are these. I need to produce at least 300, 200 and 500 units of A, B and C respectively. So, this is an important constraint. What is the constraint? That A should be more than or equal to 300, B should be greater than or equal to 200, C should be greater than or equal to 500. Need to produce this much. So, this gave me my objective function. This has given me my constraint. These two gave me my objective function. Z min, function of 8A plus 5B plus 3C. These two gave me my objective function. This has given me my 3 constraints. And these give me my yet another constraint. What constraint? Determine optimal product mix at BEP, break-even point. What is break-even point? No profit, no loss. Or in other words, where I have recovered my complete fixed cost. 12,000 is my fixed cost. Now, contributions are 2 plus 1.5 plus 1. 2, 1.5 and 1. What is contribution? Contribution is, you have studied these questions in FM, financial management. Contribution is selling price minus cost price. Cost price, no, rather let us make it variable cost. Selling price minus variable cost. Contribution is selling price minus variable cost. So, just an example. The variable cost is 8 rupees and I am selling it for 10 rupees. I am talking of A. I am selling it for 10 rupees. My variable cost is 8 rupees. What will be the contribution? 2 rupees. What do you mean by contribution? Meaning of contribution is that when I sell something for 10 rupees, the variable cost has been recovered. What is variable cost? The cost of raw material in this pan. the cost of the labor that I have put into this pen, making this pen, the cost of labor I have put into sticking this sticker. So the idea is variable cost has been recovered, 8 rupees, I have sold it for 10 rupees, variable cost has been recovered, and there is an addition of 2 rupees. So after recovering the variable cost proportion, I am left with 2 additional rupees when I sell this pen or when I sell 1 unit of A. When you sell 1 unit of A, your contribution is 2 rupees. Now it is from this contribution that I need to recover fixed also, because ultimately total cost is variable cost plus fixed cost. Variable cost has been recovered, no issues. I need to recover fixed cost also. From where do I recover this? I will be recovering this through contribution. So, how much contribution will I be getting? I am selling or producing A units of A, small a units of capital A. I am producing A units of A. So, how much contribution will I be collecting? 2 into A. 1 unit gives me a contribution of 2. Let us have a look over here. If I sell 100 units of A, how much contribution do I get? 2 is per unit, 2 contribution per unit. So, total contribution would be 200. If I sell 100 units of A, total contribution will be 200. Now, variable has been recovered because variable cost was 8, I am selling it for 10, 8 rupees have been recovered. But these two are accumulating. After selling 100 units, I have accumulated 200 rupees towards wiping off this fixed cost also. I have need to pay this fixed cost also. So, here comes our fourth constraint. What is our fourth constraint? How much contribution you will be making? I will be making a contribution of 2 into A, 2 rupees coming from A, 1.5 into B, 1.5 into B plus 1 into C. Now, because they are talking of break-even point, what is break-even point? Where my fixed costs are completely recovered. So, all these contributions need not be more than fixed cost. These need to be only 12,000 because we are talking of break-even point. So, these need to be equal to 12,000. In absence of this particular line, where I am saying minimize so that the total variable cost is minimized. What I would have tried? I would have tried to maximize these contributions. My objective function might have been, instead of this, my objective function might have been 2A plus 1.5B plus C. I want to maximize this. But because of this, I am stuck at this level. That now I will only try to recover my fixed cost, break-even point. What is break-even point? That my total contribution is equal to my fixed cost. So, this is my formulation of the given problem. What is the formulation? Let number of units of A being produced A, B and C, and Z is total variable cost. Z becomes 8A plus 5B plus 3C variable cost, individual variable cost per unit. If I add them all, 8A plus 5B plus 3C, it becomes total variable cost. Then there are constraints. Need to produce at least 300, 200 and 500 of A, B and C. 300, 200, 500 of A, B and C. And then there is another constraint. Determine optimal product mix at break-even point. To reach break-even point, my contributions need to be equal to fixed cost. These are my contributions, these are equal to fixed cost. So, this becomes my, and last one would be physical constraints. A, B, C all should be greater than or equal to 0. So, if you remember our formulations, these are our 5 issues that we used to address in our formulations. I will make use of some other color also, because everything black will get mixed. Make use of some sparkling color. Fine. So, this was the question. This is our formulating of linear problem. Now, if you remember our previous lecture, we can see greater than type of constraints. In previous lecture, we saw that whenever you come across this kind of constraint, what kind of constraint? Where a variable, single variable is greater than type of constraint. This is subject to, because these are our constraints. First constraint, second constraint, third constraint, and this becomes our fourth constraint. In previous lecture, we saw that whenever we come across this kind of constraint, we can make a substitution. Incidentally, this time all these constraints are of same type. Last time we were having two less than type of constraints and one was greater than type. So I made a substitution for greater than type constraint. This time I am having all of these as greater than type of constraints. Imagine the problem. This is a greater than type constraint. So I will be having a surplus, that is minus S1 plus A1, minus S2 plus A2, minus S3 plus A3. Making it A, B, C, then S1, S2, S3, then A1, A2, A3. 9 variables in these constraints. Then this is an equality type constraint. There would have been a 10th variable A4. These many variables. Instead, what we can do now, an assignment for you would be, this is my formulation. You go ahead and solve it in the conventional way. The conventional way would be minus S1 plus A1, minus S2 plus A2, minus S3 plus A3, and here because it is equality, I will be adding plus A4. Once again, I will be leaving you with standard form of this to solve for yourselves. For now, we will try to solve it using the trick that we learnt in previous lecture. What was that trick? Now that trick suggested that A is more than 300. So let A is equal to, it is more than 300. So I add something to 300, let it be W. A is 300 plus W. What about B? It is more than 200. Okay, 200 plus some X. What about C? 500 plus, this time let us say it is Y, W, X and Y. So I get my 3 constraints, 3 substitutions. As a result of these substitutions, what happens? What happened in last case? There was a greater than type constraint, and when I made substitution, those constraints vanished. Last time there was only one constraint, it vanished because it was included in other constraints and objective function. So now 1, 2 and 3, these 3 constraints vanish because I have made substitution. Why do I need to write a constraint about A? I already know value of A, I already know value of B, I already know value of C. So I need not write constraints about them. Yes, as far as this constraint is concerned, I will make substitutions. What is this? 2A. This is 2A. Making it A is this 2A. Plus 1.5 B. B is this 200 plus X plus 1 into C, that is simply C, 1 into C, that is 500 plus Y. All this should be equal to 12,000. This is one constraint. These 3 substitutions have ensured that these 3 constraints are gone. This is my first constraint, first and only constraint. I had 4 constraints, 3 are gone. This is the only constraint. Let me simplify this. After simplification, this becomes 600 plus 2W plus 1.5 into 200 would become 300 plus 1.5 X plus 500 plus Y is equal to 12,000. Making it 6 and 3, 9 and 5, 14. 1400 I can take onto that side. I will be left with 2W plus 1.5 X plus Y is equal to 1200 minus 1400 would make it 11,000, 10,600. So ultimately, this complete formulation is down to just one constraint. What I will do is, I will make use of some other color so that it is easier to understand. All this formulation is down to 2w plus 1.5x plus y is equal to 10,600. 1200 minus this 1400 that was taken to that side. This is my constraint. Earlier I was having 1, 2, 3, 4 constraints. These 3 are gone due to the substitution. This constraint is the only constraint. What about objective function? Objective function is 8a plus 5b plus 3c. Now if I make substitutions, the objective function would become, we need to solve it somewhere. Objective function will become z-min is equal to 8a. A has been replaced by this thing. So z-min is equal to 8. A becomes 300 plus w. 5b. 5b is 200 plus x. Plus 3c. C is 500 plus y. Fine. Now we can simplify it also. How do we simplify it? Where do we simplify it? The important question is, where do we simplify it? Instead of how do we simplify it? We'll simplify it. Okay, we'll simplify it over here itself. Z-min is equal to 8 into 300, that is 2400 plus 8w. 2400 plus 8w. This will become 1000 plus 5x plus 1000 plus 5x. And last one would become 1500 plus 3y plus 1500 plus 3y, making it, I'll write it down in fair, z-min is equal to 8w plus 5x plus 3y, 24, 34, 39, 49. This is my objective function subject to only one constraint. Subject to 2w plus 1.5x. 2w plus 1.5x. This is our plus y is equal to 10,600. Is that fine? So w, x and y. Now subject to. Now when we try to start this, this was my given question, this was my formulation. Now with help of these 3 substitutions, I have reduced this formulation. With help of this substitution, I have reduced this formulation down to only this much. Now can we go ahead and solve it? We can definitely go ahead and solve it. When we try to solve it, remember last time what happened was, I substituted decision variables and surplus variables as 0. This time I am not having decision variables, this time I am not having surplus variables, anything in this. So what do we put as 0? If we put everything as 0, I will still be stuck with this constraint, w plus x plus y. So in order to get a start, last time I said that I will not put a is equal to 0. Why? Because already x1 and x3 were equal to 0. You should definitely refer to that previous lecture in order to be able to understand the things that we are doing over here. So in previous question, you remember we put x1 and x3 is equal to 0 and we did not touch a. Because as it is x1, x3 were 0, so a was giving me a starting point. A is equal to 70, I believe it was over there. Here if I put decision variables as 0, decision variables were technically a, b and c. They are not here in my solution. So how do I start? Decision variables are not there. Surplus as 0, there are no surplus as 0. How do we put them as 0? Because there are no surplus variables. So what I'll do is, this time in order to start it, I'll say 2w plus 1.5x plus y, and I'm literally converting it into standard form. Although it is already in standard form, I'll just put a step over here to convert it, to try and convert it into standard form. This is my problem. This purple is my problem. And when I put it in standard form, I told you in previous lecture that whenever you have equalities, you make use of artificial variable. 10600. We make use of artificial variable. So I have 2w plus 1.5x plus y plus a1 is equal to 10600. And if I include this a into zmin also, then I get zmin is equal to 8w plus 5x plus 3y plus, this is minimization type problem. So it will be plus m, a1 plus there is a constant term which doesn't hurt us. We'll leave it over there. So I have my standard form. I'm making use of artificial variable. Yes, this does not look like transformation to standard form because I was not having any kind of inequalities. But still, we make this step so that I can introduce an artificial variable over here. What this introduction of artificial variable does is, when I try to find out IBFS, what will be the IBFS? This is 0, this is 0, this is 0. Put w, x, y is equal to 0, giving me IBFS as a1 is equal to 10600. a1 is 10600. Now if I get IBFS, can I start with my solution? What are the variables in Z? W, x, y, and then there is an a1. There will be b and theta. What are the contributions? 8, 5, 3, m. IBFS is a1 is equal to 10600. Only one constraint I have this time. What is the constraint? 2, 1.5, 2, 1.5, 1, 1. What is the contribution of a1? See, this is simplex. Business as usual. I have Cj, I'll have Zj. Zj is sum product of every column with contribution. So it will be 2 into m, 2m, 1.5 m, m, 1.5 into m, 1 into m, 1 into m. Then because it is minimization type of problem, I'll do Zj minus Cj. Zj minus Cj would give me 2m minus 8. 2m minus 8. This would give me 1.5m minus 5. This will give me m minus 3 and this will give me 0. Now this is 0. No issues at all. What about this? What do I do with minus 3, minus 5, minus 8? Remember, m is such a large number that addition or subtraction of 8, 5 or 3 will not affect its practical value. Theoretically, yes, it might get reduced, but practically it will not affect the value. So, if practically it does not affect the value, which one is the greatest? In earlier days, in earlier lectures, I also gave you a method to identify which one is the largest. Give m some very large value. Let us say that m is 1 lakh. If m is 1 lakh, what will this value be? 2 lakh minus 8. This will be 1.5 lakh minus 5 and this will be 1 lakh minus 3. This is as it is 0. Now, can you tell me which one is largest? 1 lakh minus 3 is almost 1 lakh. 1 lakh, 1.5 lakh minus 5 is 1.5 lakh, almost 1.5 lakh. And this is almost 2 lakh. Which is the largest one? 2 lakh. That is 2m is the largest one. If you remember our earlier lectures, we saw how to identify which one is the largest. So this is the largest. If this is the largest, so this gives me my key column. Obviously, there is only one row. Theta would be 10600 upon 2, that is 5300. The least positive is only this because there is only one. So let me go to my second simplex table. Artificial variable is this is key row, this is key column. Incoming, this was 0. This is key column, this is key row. Key column, that is W is the incoming variable and incoming variable is W. Outgoing variable is A1. So artificial, when it moves out of my solution, I forget it forever, leaving me with W, X and Y. There will be no A. W, X and Y contributions are 8, 5 and 3. I have B, I have theta. Contribution of W is 8. Now, this is key row. How do we transfer key row? By dividing all elements by key element. What is the key element over here? This is key column. This is key row. 2 is my key element. So, divide everything by 2. 2 divided by 2 would give me 1.5 divided by 2 would give me 3 by 4. 1 divided by 2 would give me 1 by 2. And 10,600 divided by 2 would give me 5,300. I have 8. Can I find Cj's? I have Zj. Can I find out Zj? This will give me 8. 3 by 4 into 8. 4, 2, 6, 4. So, I have my Zj's. 3 by 4 into 8. 1 by 2 into 8. Then I will be having Zj minus Cj. Zj minus Cj would be 8 minus 8. 0. 6 minus 5. 1. 4 minus 3. 1. So, we get a 0, but then there are 2 1s. So, inclusion of X into my solution will increase my profit, or rather I am trying to minimize, it will minimize my costs by 1. This will also minimize my costs by 1. So, both are equal. So, you could take either of these. So, let us say we take X, or we could have taken Y. If I take X, what happens? If we take this one as valid, so this becomes key column and this will definitely become key row, because it will be 5,300 upon this, whatever it is, it will be positive, and because this is only row, obviously this has to be my key row. So, I have key row and I have key column. This is my key row, this is my key column, and intersection of these two will give me my key element. Let us move to our next matrix. What will be our next matrix? If we move to our next matrix, it will be W, X and Y. W, X and Y, B and theta. Now, this is key row. How do we transfer key row? Dividing everything by key row. Divide everything by 3 by 4. If you divide 1 by 3 by 4, it becomes 4 by 3. This will become 1. If you divide half by 3 by 4, it will become 2 by 3. If you divide 5,300 by 3 by 4, it will become 5,300 divided by 3 by 4. We'll make it 7066.66. 7066.66. And W is outgoing variable, instead X is the incoming variable. Contributions being 8, 5 and 3. 8, 5 and 3. X has a contribution of 5. This is Cj, this will be Zj. What will be the Zj? 5 4s are 20, 20 divided by 3. 5, this will be 10 by 3. If I talk of Zj minus Cj, it will be 20, Zj minus Cj, 20 minus 24 giving me minus 4 by 3. 5 minus 5 will be giving me 0. This will give me 10 minus 9, 1 by 3. So, negative 0, this is positive, giving me my key column, and 7,066 divided by 2 by 3 will be something positive. So, this will be my key row. So, this time I have key row, I have key column, and intersection is key element. Now, we are running short of space. So, what I will do is, I will have to remove something. I will remove this table. first table. I'll remove the first table. We have W, X, Y, B and theta. X is outgoing variable, Y is incoming variable. We have Y, contributions are 8, 5 and 3, 8, 5 and 3, Y contributing 3. Transfer key row by dividing it by key element. 2 by 3 divided by 2 by 3 would be 1. 1 divided by 2 by 3 would be 3 by 2. 4 by 3 divided by 3, this will be 2. I have Cj, I can have Zj, 3 2s are 6, 3 3s are 9, 4.5, giving me 3. Zj minus Cj. This would be 7066 divided by 2 by 3. 10,600. Zj minus Cj would be 6 minus 8 minus 2. 4.5 minus 5 minus 0.5. 3 minus 3, 0. So everything is either 0 or negative. So I can say that this is my final solution. What is my final solution? My final solution is y is equal to 10,600. Let me go to this substitution. We'll again be needing some space. So this is my final table because everything is negative or 0, so I can stop at this point. And what is my final solution? My final solution is y is equal to 10,600. But nobody asked me about y. Or in fact from here I can say that I started with w, x and y. So y is 0, y is 10,600, w is 0, x is 0. This is my final solution. But nobody asked me about w, x and y. Rather, I was asked about number of units of A, number of units of B, number of units of C, that is A, B and C. Now, if I know that x is 0, if I know that w is 0, if I know that y is 10,600, can I not substitute them over here? So, if I substitute these values over here, A is equal to 300 plus w, making it 300 plus 0, making it 300. Similarly, number of units of B, 200 plus x. 200 plus x, x is again 0, 200 plus 0 making it 200. Then C is 500 plus y, that is 10,600, making it 11,100. So I can say that my final solution is number of units of A, 300, number of units of B, 200, number of units of C, 11,100. For minimum variable cost, 8A, 5B plus 3C, making it 8A, 8 into 300, 5 multiplied by 200 plus 3 multiplied by 11,100, total being 8 3s are 2,400, 5 2s are 1,000, 33300. This will be my total variable cost. How much is this? 33300 plus 3400, 36700. So you can go ahead and produce 300 units of A, 200 units of B and 11,100 units of C, so as to minimize the total variable cost at BEP. If you produce these many units, ultimately you would have recovered your 12,000 rupees. Would you have recovered or not? Let me see. A is contributing me 2 rupees. So if I produce 300 units, how much do I get? Contribution, we are just talking of contribution, just checking it. That have we reached the BEP or not? Have we recovered our fixed costs or not? 2 rupees per unit is the contribution. I am producing 300 units, making it 600. Contribution of 600. 300 units I will produce. 2 rupees per unit is contribution. I get 600 rupees as my contribution. 200 units I produced. 1.5 is the contribution. So giving me a contribution of 300. And 11,100 multiplied by 1 plus 11,100, giving me a total contribution of 12,000, which was my fixed cost. So if I have recovered all my fixed cost as these amounts, which means I am at BEP with minimum variable cost of 36,700. This is the minimum that I will have to spend on this. So we had our question, we formulated it, we came across these kind of constraints, which we talked last time that they can be easily substituted. If we substitute them, you can see the tables, such small tables. And if we had gone the conventional way about these, the tables would have been big, the calculations would have been big. In either case, this was our solution, this was our formulation, this was a little substitution. This substitution removed these 3 constraints and transformed this constraint into this. Transformed this constraint. Here we have done calculation, transformed this constraint into this. So these 3 were removed as a result of this substitution. This was transformed into this, while objective function was transformed into some other objective function. Then I solved it using Simplex. Yes, this time I started with an artificial variable because everything would have been 0. See, we need some criteria. You cannot say that put w is equal to 0, x, do not put x is equal to 0. You simply say either put decision variable is equal to 0, slack variable is equal to 0. This is how we proceed. So in this case, if I had put w is equal to 0, I would have had to put x is equal to 0, y is equal to 0. So when I put all these 0, it would become 0 is equal to 10,600. So what I did was I made use of artificial variable. As it is, we know that in equality kind of constraints, it was an equality kind of constraint. In equality kind of constraints, we make use of artificial variable. So I made use of artificial variable. And as a result of this artificial variable, my objective function also had to include this artificial variable. And I made use of big M method. Because this was minimization type problem, I used plus M. Had it been maximization type of problem, I would have used minus M. Then I solved it. Now I have removed those tables, so I cannot show you them, but I solved this using this. And ultimately we reached a solution of this, where y was 10,600, w and x were 0, and then I remembered that actual values were a, b and c. So I made these w, x, y substitutions and my a, b, c came out as 300, 200 and 11,100, giving me z min of 36,700. And just to check, this was only a check, this was not required, I just checked that have I recovered my complete fixed cost or not. I have recovered my complete fixed cost also. This was our solution using what we have learned in last lecture, previous lecture, a special case. Special case, what special case? Special case of these kind of constraints. Now, if you had tried doing it the conventional way, your formulation would have been, I'll remove these. If you had tried doing it conventional way, then your formulations would have been your formulation would have, your standard form would have been A minus S1 plus A1 is equal to 300, B minus S2 plus A2 is equal to 200, C minus S3 plus A3 is equal to 500, and fourth would have become 2A plus 1.5B plus C, and because this is equality, I would have made use of artificial constraint 4 is equal to 12,000. Now this is the normal routine simplex that we would have done if we had not made use of this substitution. This would have been our normal standard form. All constraints have been converted into equalities, inequalities have been converted into equalities, and objective function would have been zmin is equal to 8a plus 5b plus 3c, and then plus 0 s1 plus 0 s2 plus 0 s3. And being minimization, it would have been plus m a1 plus m a2 plus m a3 plus m a4. So this was it for our today's discussion, where we had this problem, we formulated it, we made use of substitutions, thereby we solved it to get to these answers. And this is if you wish to solve this problem without making use of this substitution. If you do not feel like making this substitution, if you do not feel like solving it the way we solved it over here, then this is a simple problem. You could go ahead and solve it. You have your constraints 1, 2, 3. I've even converted them into standard form. So we have first constraint, we have second, third and fourth constraint. This is your objective function. I could get you a glimpse into what your table would look like. It would be A, B, C, S1, S2, S3, A1, A2, A3, A4, B and theta. This would be your table. You have 4 constraints. Your contributions coming from Zmin would be 8, 5, 3, 0, 0, 0, M, M, M and M. IBFS would be A1, A2, A3, A4, 300, 200, 500 and last one would be 12,000. Contributions being M, 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 M. You can fill in these constraints also. First constraint is 1, minus 1, 1. Everything else being 0. Second constraint is 1, minus 1, 1. Everything else is 0. Third constraint is 1, minus 1, 1. Remaining else is 0. And last constraint would have been 2, 1.5, 1, 0, 0, 0, 0, 0, 0, 1. You could have gone ahead and solved this. So you can imagine this is one simplex table. Now you'll go through your multiple simplex tables, multiple iterations to reach ultimately this answer. And if you have seen this video carefully, just as a result of this tiny little substitution, how simplified our calculations became. This is the conventional way, this is the new way that we have learned by making use of substitution. If ever you come across a constraint of greater than type with one variable on LHS, only one variable on LHS and greater type constraint, you can always make these substitutions. So this was it for our today's lecture. Thanks for watching. Bye bye. Take care.